Okay then, let's get into exploring a few more things about GIS, and this time around we're going to be focusing on terrain and how terrain can be analyzed, modeled, and visualized. So what we're going to do first is take a look here at our catalog. I've got a few things already prepared, just data sets in general prepared, but I'm going to go through and do some other things with them, show you a bunch of things today. So here in our catalog, I've got a folder already set up for Practical 3, and it is doing, or what I'm going to be doing here are some of the things related to Practical 3. I'm going to be demonstrating a little bit about these different data sets. Here we've got a Landsat image for Bonner County already prepared for you in some ways. We can do some things with that. Here we've got a data set that tells us something about the landscape vegetation patterns. It's from the GAP program, the Geographic Analysis Program. And we want to get the information for Bonner County out of this. We'll do that a little bit later. We have a DEM of the county, and then a bunch of data sets that you should be already a little bit familiar with from the prior practicals. The admin set, hydro set, and linear set. These are just here, not necessarily things that you need for Practical 3. You will need a few of these things perhaps, but for the purposes of this demonstration, I'm going to need something in particular out of one of these data sets in order to show you some processes later on. So I've got my database structure, all the project database overall set in place here. So I'm going to close that out, and I don't need to work in our catalog anymore, I believe, so I'm just going to shut it down. And now we're going to jump into ArcMap, and I'm going to add some things in to the data table of contents, assuming that it actually works. Let's see here. There we go. All right. Make sure I'm in the right spot. I'm not in the right spot. I want to be working in Practical 3 and the data sets that are here. So the first thing that I'm going to be adding in is going to be, I'll add that one in. No, actually we don't want to do that. Remember that the first thing we add in is going to set the data frame properties. So actually what I'm going to do is go after the counties data set, and then we'll bring in, notice that I've added here a different folder. This is something that I've recently decided I should probably do, since there are so many things that we can do, what we can call terrain data sets, is that I'm storing the DEM and any of the products that I create off the DEM in a folder called terrain. And that's something that I've kind of discovered is going to be an important thing in the long run for me to be able to do that. And it's something that an organization might do. They might change their practices over time. So I'm going to store things that are related to terrain in a terrain folder. What else do I need to do here right now? That's probably going to be all I'm going to need for the moment here in ArcMap. We're going to be doing some things in ArcMap and also in another module of ArcGIS. So I think that's about all I need for the moment. So I'm just going to go in here and go through an operation that you've done before. I'll just do it for practice. I want Bonner County by itself. So I go into the county's data set, select it, and now I'm going to export that data. Make sure it's going to the right place. In my folder connections, standalone vector data set is what I'm going to create, and I'm going to create it outside of the admin set just to keep it separate. And I'll just call it County Outline. And didn't like that because I tried to save it as a geodatabase instead of a shapefile. So there we go. We've now got the county. by itself. We'll make it see-through. And we'll get rid of the admin counties data set in general. We don't need that anymore. And now we've got the DEM, we've got the county outline. Okay, so we'll use that outline a little bit later. Right now I'm going to open up our toolbox and I will double check and make sure that I've got the appropriate extension, and I don't have it selected yet. So I'll want Spatial Analyst because I'm doing things in Spatial Analyst that will generate new data sets from the DEM. So go to Arc Toolbox, go to Spatial Analyst. There's a variety of tools available here that focus on doing things with DEMs, and what I'm going to be using is the surface tools. So I'll go in here and I'll create a number of these things just for a demonstration, just for the sake of demonstration, and also because we're going to use them later. So I will generate first aspect, and my input raster will be the DEM. My output is not going where I want it to go, so I need to make sure that it is pointed in the right direction. And since this is a terrain data set, I'm going to keep things in terrain, and that is something that I'm just using as a way to separate out these rasters from the other rasters. I'll call it Bonner County Aspect raster data set, and I will use the default options. And what Aspect does is it creates a raster grid that indicates the compass direction that cells are facing. So the aspect would be, if it's a north aspect, it's facing north. If it's a west aspect, it's facing west. If it's flat, like a lake, it's not pointing in any particular direction at all. And so that's what all these colors are showing us here, this rainbow of colors for these different directions on the compass, and they have with them associated the degrees starting from 0, ending at 360, and on a compass both of those mean the same thing. They're pointing directly north. And so when you're interpreting the colors out here, you need to refer back to the table of contents to know, well, what is it that my color is referring to. Here the reds are referring to north from 0 to 22.5 degrees, and here's also north from 337.5 to 360. So it's a wedge that points to the north. There's a wedge here that points to the northwest, a wedge that points to the east, and that's what it is. And this is important because the orientation of the landscape toward different compass directions is important for understanding something related very closely to solar radiation and how much warming that area is going to receive. If it's a south-facing slope, it's going to get more sunshine throughout the year than a north-facing slope. A north-facing slope is going to be cooler. It's going to be wetter. A south-facing slope will be warmer and drier. So there are some environmental characteristics that go into these things. All right, so let's go and create some more things. Let's look at slope. There's another good one. So we'll use the DEM, generate EC slope. We are going to do it in degrees and use the other default options. Slope can be generated either in degrees or percent. If you are from a major or a career that uses percent slope instead of degrees, you have the option of doing that. I'm just going to use degrees. That's typically what I prefer to have my slope values in. And slope, as the name implies, what it is it's going to be comparing the cells in the DEM and then calculating the angle between the higher elevation and lower elevation cells, and then display it. And there we go. And there's our ranges for 0 slope up to, in this case, the maximum slope for this DEM apparently is 52 degrees, almost 53 degrees, which is pretty steep. On the color range here, just they like to use these bilinear ones for some reason on the default slopes. But there it is. That's what we're looking at there. Where you expect it to be less of a slope on the lakes, some of the river valleys, some of the floodplains are going to be flatter, and that's what we're seeing here for Bonner County. So what I'm going to do to make this thing work a little bit easier, I'm going to turn off a couple of these just because we don't need to see them, and it's going to make the display run a little bit quicker. The data's still there. It's accessible in the project, but I just don't want to see it. I don't want it to be continually redrawing, so I'm just going to turn that off. And the next thing we're going to do is generate a hillshade. So we'll go again with DEM. And what a hillshade is, the options that we have here directly relate to it, the azimuth and the altitude. So the azimuth, this is the compass direction where the sun is located. And the altitude is degrees above the horizon. So right now the sun is at 315 degrees, so somewhere off to the northwest, and at an altitude of 45 degrees above the horizon. This is what's known as Swiss hillshade modeling, and this is what gives, according to the Swiss cartographic tradition, it produces a pleasant looking hillshade. And so what the hillshade is, as the name implies, it's going to be looking at where the sunlight lights up the landscape and where it creates shadows. So it'll come out as a grayscale, and it will eventually display here in black and white as a grayscale image basically showing terrain. And it's something that you might see in textbooks and in reports as a method for portraying the landscape. So I'm just going to zoom in a little bit. Whoops. Let's see here. Let's turn off the DEM. And then maybe I'll just use that. And let's zoom in a little bit and see what's happening in here. So we're seeing an idea of what the terrain looks like. Here's ridge lines, valleys and slopes, flatter areas. And when you zoom in a little bit closer, you can see there's some artifacts left behind from the DEM, these squiggly little lines. You're probably not going to see those on the landscape. And if we zoom in even closer, it's going to look a little bit odder. But anyway, what the hillshade does, this shows you, gives you an idea of what the terrain is like. And it's something that's often used as a background or a backdrop, that you can contrast other things against. Let's see, I might as well do that while I'm thinking about it. Let's pull in another vector data set. Oh, let's find the roads. And so here you can see, here's an unclipped version of the roads for the county, and the gray background of the hillshade is a nice contrast against the default color here with some shade of a blue for the road network. And so it's just, it's kind of a nice neutral thing to have in there as a background data set. All right, so I think that's about all I need to do here in ArcMap. So I've created those data sets, and we're going to use a few of them to do some other things. There are a lot of tools available to you here in Spatial Analyst to use to create terrain. The surface ones are the ones you use most often. If you needed to create solar radiation data sets, here they are. If you needed to work in hydrology or groundwater, those tools are there. Those are things that you might come across in more detail in other classes. So I think what I'm going to do, whoops, I'm going to close that out. And maybe just for the sake of practice, let's save the MXD file. And we're going to save it in Practical 3, in Practical 3, in the reports folder. And I'll just call this Practical 3 demo. I'm actually not going to use this again. but I'm just going to save it here in case I need to open it up for some other reason later on. And we're done in ArcMap. And now we're going to open up another module of ArcGIS, which is called ArcScene. And ArcScene, you already have it installed on your computer. It's part of the ArcGIS installation. Notice that here I've got, again, menu across the top. I've got tools that I can use. Some of the tools are similar to what you've already experienced in both ArcCatalog and in ArcMap. Some of them are not. They're very different. But we do have access to the catalog here if you like that particular way of dealing with the data sets. We have access to Arc Toolbox here. Not necessarily all of the tools that are available in ArcMap, but definitely ones that are related to things in 3D. This is what we're working with, is primarily in ArcScene is 3D representation. So what I'm going to do here is pull in some data sets. I normally don't do this, but I'm going to demonstrate it. I see students doing this all the time in the lab, so it must be something that gets that price covers, or they pick up somehow. But I usually do the old-fashioned way of pulling data in, but here I'll just grab things, pull the data sets in, and then we've got a very different interface for dealing with the data set. So I can grab it with my mouse. I'm left clicking, and then I can move it around, and I can look at this thing and see underneath it. I can look right at it. And you're wondering, well, he mentioned that this was 3D. So how do we get this thing to be 3D? Well, there's a couple of things that we need to set. So I'm going to go first off to the scene properties. I right click on that to bring those up. And then I'm going to modify what's called vertical exaggeration. And I'm going to do this, even though you haven't seen anything in 3D yet, I'm going to exaggerate the terrain a little bit to make it a little bit more prominent. So I am going to select a vertical exaggeration of 2. Apply it to the scene. And we still aren't seeing anything in 3D. I have to go to the data set, BCDEM. And this may seem a little bit odd, but under this tab for the layer properties, right now we're saying no elevation from a surface, so it's flat. I want to float on a custom surface, and a surface in this case is going to be some data set that contains elevation values or something that we can use as elevation values, and that's going to be the DEM. So another option that I have is cell raster resolution, and this is going to be the size of the cells that get shown here in the interface. And so the original surface, the DEM, is 30 by 30 meters on the sides of the cell, this many rows and columns. And what ArcScene wants to do by default is say, well, I'm going to just resample that kind of on the fly, and I want to show you things that are 1.7 kilometers in cell size, and that's probably a little bit too big. I think what I'm going to do, for the sake of demonstration here, I'm going to pick 500 meter cell size, which is a reduced set of rows and columns. And what this does in practice is that it's going to render slower than the default options that it wanted to use, but it's going to render faster than if I use a 30 meter by 30 meter visualization. So I'll apply that. And now we see some hints of terrain in here. Okay, let's zoom in a little bit. And now, see, we have some texture. The mountains and valleys, the ridge lines, the drainages. And this is the DEM draped on the DEM. Think of it like a blanket draped over a table if you're making a fort for your kids or for your nieces and nephews or something like that. This is kind of how that's working. We're draping the information about the DEM using the elevation values from the DEM to see the landscape. So I'm going to go in here and I'm going to change the vertical exaggeration again. Let's change it to something a little bit more drastic. Let's go to 5. And now you can really see, all right, look, there's mountains, there's valleys, and the drainage basins are very much exaggerated, but we're exaggerating them in order to notice them, basically. At the scale of the county, mountains don't look as big as they do if you're standing next to a mountain in the valley right in front of it. Okay, so we're just manipulating exaggeration to literally exaggerate the features so that they show up. Okay, so there we go. I'll just leave it at that exaggeration. Now we can see the full extent, and you can see some artifacts from creation of the DEM in there. But still, it's a nice visualization of the terrain. Let's add in a few more things. Let's add in the slope. And we want to build pyramids. Yes, I will build pyramids. Pyramids allow faster rendering of the data sets for complex data sets. So we've got the DEM. I'm going to turn the DEM off. And now what we're seeing here is slope. And currently, slope is flat because it is not deriving base heights from anything. We're going to change that. We're going to get the base heights from the DEM. And since I turned off the DEM, I don't have to worry about setting an offset. But if I wanted to have the DEM render underneath this, I'd use an offset. Well, maybe we should do that just to see what happens. Let's set an offset of 15. We'll apply that. And then let's turn the DEM back on again underneath in the background and look at it from the side. And maybe that's not enough of an offset to really see it. Okay, well, we won't worry about that for now. Anyway, so there are the slope values, and notice that they are not multicolored anymore. Okay, the default setting that worked in ArcMap does not apply here. So we would have to go in and create our own version of a color ramp, either using one of the default selections or create your own color ramp from what you learned in cartography. So just for the sake of argument, let's just apply one to I'm just picking one at random and apply that to it. And that's really not a good choice, is it? That's horrible for showing things here. Let's do that again. Let's find something. Maybe I'm not going to be able to find something that's really pleasing to the eye. But I will give one more try here. Okay, that's not too bad. A sepia tone. Anyhow, then we see now that this is draped, and it's showing us the slope values in degrees associated with the DEM underneath. And so the higher slope areas we can see here right on this cliff face around the lake. And other ridge lines, it makes sense. You see steeper areas there and less severe slopes out in the flatter areas. Okay, so there's a nice correlation going on there between things. That's great. Let's add in, well, let's see here. What else should I do? Oh, nuts. I did forget something. Okay. We're going to add back in, I'm going to add ArcMap back into things. Let's see here. What else can I do while that's loading up in the background? Obviously, I'm working without a script again. I like to do that, even though sometimes it's embarrassing. I forget to do things. So let's add in the roads, and now we can see, well, the roads are flat. They're not grabbing anything, so they're not showing very well. Let's go to the properties for that. And there's our base heights. We'll put them on the DEM. Apply them to the DEM. but they're not showing up quite right. And why might that be? That's because we were having the slope actually float above with an offset. So we'll take that offset away. And now we can see more of the roads. But if I really want the roads to show up against the background, I'll go back to the base heights here. So here's where I'll create an offset, and I'll create an offset just of, I think I'll do 15, because I did that before. That's a value that you can play around with a little bit, and to see what's going to give you the best result. And now we can really see that this road network is showing up a lot better against the background, and that's because it's actually floating above it. If you looked and zoomed in on this a little bit closer, you'd see that the roads layer is slightly hovering above the slope and above the DEM. And so that's something you can use to help visualize things in 3D a little bit better. Okay, so I forgot to do something back in ArcMap, and we're going to go and load that back up again. I'm sorry, I forgot there was something else that I was going to demonstrate, and I neglected to do it here. So I'll do it now, and we'll turn off the hillshade, turn off the road network, and then we will use the folder connections to go back in, and we're going to grab in the gap data. Here's what I forgot to do. So we've got the gap data, and I want to do this in ArcMap rather than ArcScene because I have access to a particular tool here. So I'm going to go into the county outline, open the table, and I'm going to make sure that I select this polygon. I want the polygon active. And I can use it now. I'm going to show you a way to clip data sets that's a little bit faster than some of the things you may have done before. So here under the Windows menu, I'm going to pull up Image Analysis. And Image Analysis gets used in conjunction with satellite imagery primarily, but we can do a few things with it with other rasters, including this, which is really quick and fun. I think it's a really fun way to deal with data. So I've got the gap data here, I've selected it, and now a lot of things became active down here, including these tools. And if I hover above the tools, it's going to tell me what each tool can do. And the one I want is this one. I want to clip. And the way that this works is that I can clip using polygons, graphics, and maybe a couple of other things. But since I have a data set that's the county as an outline, this can become a cookie cutter. And as long as it's active and selected, as I did here, it's active, selected, boom. I've got this raster active. Now this tool will work, and it's going to clip. And you're wondering, did it happen that fast? And yes, it actually did. So if I turn off the gap network, or the gap data set, then I've got the data here. Let's see here, let's look in the properties and see. It's a temporary data set. So it says folder, users, hunter, temp. So this is temporary. This is not a permanent data set yet. So this is something that you need to be aware of. Even though you're seeing things here in the table of contents and it's displaying over here, this is temporary. It's just stored in temporary space. It is not yet something that we want to deal with or something that we can share with someone else. So I need to export that data, and I'm going to go through and I'm going to pick for this demonstration, I'm just going to pick the default options. Here's the original cell size, 30 by 30. I'm not going to compress it. I don't want it to go to the vector folder. I want it to go back into the raster folder. I'll call it BC gap. And it won't let me do that because actually what it's looking for here is the folder. So it wants raster as the folder, and down here is the file name, BC gap. I'll keep it in TIFF format, keep everything the same. Now what I could do here is I could say, do I want to reproject this at this point in time or not? So I can just say the raster data set is going to keep the spatial reference from the original data set, which is not going, it's not in the same projection system as my all my other Bonner County data. Well, maybe I should do that. Let's just see what happens. So I'll just say data frame, and it says, oh, I want to resample. Well, we don't really want to do that. We want to keep it. Well, no, I don't want to do that. That's right. That might take a little while. Sorry. You can try that if you want to. I'm just going to keep it simple. I don't want to sit here for 20 minutes. If it's going to take 20 minutes, I don't know how long it's going to take. But that's an option that I could do if I wanted to. For the moment, I'm not going to. I'm just going to say, let's use the original data, and there we go. So we added it back. The BC gap data, I remove it here, and I've got it showing here. So now the gap data is there. So I can clip pretty much any raster using this technique. And now this data set is stored in the raster folder. It's available to me. That's a quick and easy way to deal with clipping operations with rasters, which sometimes can be a problem. You can mask them. You can use the polygon or raster mask within processes sometimes to do it. I find that this is a real simple way to accomplish that particular operation. So then I can close out this. I don't need that anymore. Is there anything else that I could do here that would be useful for you folks to know? I'm thinking on the fly. And there's one other thing that I could probably do. Or maybe there's two other things that I could do. No, there's two other things that we could do. All right, let's do those. Let's do both of them. So image analysis, I'll turn off the gap data so we don't have it displayed anymore. And let's add in, let's add in another data set. There is something else that I can show you that you may find useful. And I'm going to add in the Landsat data. So this is a 4-band Landsat image. It's got red, green, blue, and infrared. So what I can do over here, let's see. I'm changing to 1. So band 1 is actually the blue color spectrum. Band 2 is the green. Band 3 is the red. So when this initially brings in the Landsat image, it's assigning the wrong bands to the red, green, and blue color spectrum. What about this 4? So 4 is infrared. So this is something that's called a false color composite. And what we've done with this is a commonly used thing in natural resources, is that wherever you see red, red is showing us healthy vegetation. And the different tones or shades of red are telling us something about the structure of the vegetation, if it's grass, if it's trees, shrubs, things like that, how healthy it is. There's a lot of analysis that you can do using these things. We're not going to go into that in this class. That's something that's more of a remote sensing class. What we can do, though, let's zoom in on Sandpoint here. The urban areas show up as these blues and whites, the roads, the parking lots, the buildings. So you can really differentiate this natural structures from the built-up urban environment. Okay, really handy, really neat to be able to do this. And this is one of the simple things that we can do using remote sensing technology. But one of the things that we can use here, another data set that we can calculate from a Landsat image or from other images that have red, green, blue, and infrared, is something called an NDVI, a Normalized Difference Vegetation Index. So I'm going to activate this, and then I'm going to go up here to the options for the tool, and there are a number of things that you can do in this tool set. NDVI is a combination of the red band and the infrared band using an equation. We're going to use the wavelengths, and we want scientific output. Okay. If we don't click scientific output, we're going to get something that's not as useful. So we want scientific output, and it's going to generate that for us. When I click on the leaf over here, which is the NDVI. So I just click on the button, and it does the computation for me. Boom. There we go. We've got an NDVI shown as a grayscale from negative numbers to positive numbers, fraction or decimal places, a fraction of 1. So where the index is higher, we've got more vegetation. So we click this on, click it off, and you can see that based on the image, we've got vegetation. We've got the blacker areas, not so vegetated. Darker grays, not as vegetated. Got a little bit more bare soil in here. We've got trees up in here and over here. Okay. That reflection is showing us that nicely. And if we go back and change the red band again, say, darker. Where there's darker green, there's darker reds. There's trees in those areas. So this is just an example of something that we can do with remote sensing imagery to analyze. That's a real simple analysis to NDVI. Usually we use the NDVI in a type of an investigation, but that's how we can generate it really quick and easy here in ArcGIS. Okay, so then that's probably all I need to do with that one. Let's unactivate the data set there. And then what else can we do here? I'll keep the county up. Let's go back to the DEM. So there's one other thing that I should probably do here, and that's create a data set that really isn't talked about in your textbook at all. And so we'll get into that a little bit here. And it's called a topographic position index. And let's see what we can do to create that. So what I want to do is bring up the raster calculator again. Well, I want to bring up the raster calculator, excuse me. Haven't done it yet. That's here in map algebra. So bring up raster calculator. And I'm going to want to create a couple data sets off the DEM. So we're going to create, let's see. Oh, wait a minute. No, I'm using the wrong tool set, aren't I? Darn it. I should really write this stuff down. Spatial analyst. And then I want to go to the neighborhood tools. Correct. I want to go to the neighborhood tools. I want to do focal statistics. So my input raster is going to be the DEM. There's going to be several layers that I want to create out of this. I want to create the mean, the minimum, and the maximum. So I'm going to create those three things of this. The input raster is my DEM. My output raster is going to go into terrain, and it's going to be call, let's see here, I'll call it TPI mean, topographic position index, the mean. And I'll create, let's make this one a little bit faster to process. We'll create, actually let's create a 9x9. A 9x9 neighborhood. Keep it odd numbers. And we just want to create the mean out of that. So what it's going to do is it's going to use the DEM. It's going to give us we're going to use a rectangular neighborhood of 9 cells by 9 cells. It's going to calculate the mean of those. So focal statistics in the neighborhood toolset are neighborhood statistics, which you may see in the literature described either as a focal raster, a focal neighborhood, a neighborhood. There's a number of different things that they would call them in the literature, but basically it's what we talked about in the lecture. It's where you take that the neighborhood of cells, of adjoining cells in a 9x9 grid or 9x9 sample of the overall raster grid, and it creates the statistics for it in this case. And those statistics are here, the mean. So we're getting mean values in the raster. Okay, so let's pull out our toolbox again. We'll do another focal statistic. We'll have the input raster be the DEM. The output is going to be TPI minimum, rectangle, 9x9. And in this case, the drop-down statistic is going to be minimum. So the equation that we're eventually going to build to create the topographic position index is really similar to the NDVI equation. And the NDVI equation is described in ArcGIS Help. You'd be able to read it there if you want to know more information about what it is and get an idea about what you can do with the NDVI, a little bit more detail there. But the topographic position index is something that looks at where cells are located in relation to each other. So cells that are at the top of a ridge compared to the cells that are at the bottom of the ridge in a drainage along a stream or in a valley, something like that. And so the values that you wind up with from this index are going to be telling you kind of if your cell location is on a ridge line or at a valley bottom. So we need to run one more statistic here off the DEM, the TPI max. So the 9x9 focal neighborhood that did the mean is calculating an average of those cells in the 9x9 or in the 9x9 neighborhood. The minimum will be it'll sample all of those cells in the 9x9 focal neighborhood and then apply the minimum value, and then obviously the max will be looking at that 9x9 neighborhood and getting the maximum value out, and that's what goes into the target cell. So remember from the lectures that these focal neighborhoods, these focal samples, each one of them is a moving window of 9x9 cells, and the central target cell is the one that receives the calculated value. So we're doing that using this roving window for the entire grid to generate the mean, the minimum, and the maximum values. And now we've got those. So then let's go. Now we go where I was wanting to go right at the beginning. We want to go to use map algebra, the raster calculator. And so now we're going to use raster calculator to build an equation that'll give us the topographic position index. So I'm going to use parentheses to separate out these things from each other. So the TPI mean subtract, yeah, it's right in front of me, that's why I can't see it. And then we're going to subtract the minimum from that. So that's the top part of our fraction or our division problem, will be the mean subtract the maximum. And we're going to divide that by another parenthetical, the maximum subtract the minimum. Okay, and so then our equation is a logical SQL equation. It's a logical SQL statement. We want to put the output raster right here. We're just going to call it BC TPI. So then I know that this one's different from these other ones here. These are my intermediate data sets that I've created in the process, which I signified by TPI to make sure that I know that that's what these things are referring to. They're the topographic position index elements of maximum, minimum, and mean values. And now I'm generating for the Bonner County the topographic position index. So I'm just using that acronym, and we're going to run and evaluate that expression. And when it's done, we'll have that as another data set that we could use in analysis of the environment of Bonner County. And it's a terrain-related analytical product. So that's why I'm showing it here. All right, so we've got the TPI. It's stalled out for a second down here. It's trying to come up and tell us something about it. There we go. Created the topographic position index. And so then I'm going to turn off maximum, minimum, and mean. And then I'll turn off the county outline, turn off the DEM. And so we've got some interesting artifacts, if you look out here. Let's look at what's happening out here. It's kind of a mess. These weird shaped things, this weird texture that's out here, this is the lake. So if we really wanted to clean this thing up, we could remove that by clipping out the hydro features. We could clip out the lakes and then remove those things from it, but it doesn't really matter for the analysis that we're doing at the moment anyway. And so what we can see here, let's look at an area with a drainage right here. There's a nice dendritic drainage. Let's zoom in on this, and then if we click on our info tool, we will see, let's probe that. The BC TPI value 0.52. .77. Down here at the bottom of a ridge, 0.44. Closer to the top of a ridge, it's closer to 1. So that's what we're seeing on the terrain, the values that are in here. Let's zoom back out. So there's another data product that we can use there in ArcMap. Okay, so there's a few things that we can generate in ArcMap and how we can look at things in ArcScene in 3D You can drape most things over terrain here in ArcScene using either a DEM or a tin as a backdrop. We can generate tins. Well, let's see. We can probably do that here. Let's make that the last thing that we're going to do. If I want to create a tin, and of course I always forget where this actually is. Raster to tin. Okay. So I'm going to turn off slope. I'm going to turn off roads. Let's create off the DEM. We're going to put it in here. BC10 Z tolerance, and that tells us the Z tolerance is used to say how far up and down we're going to be searching to find cells to generate our surface. I'm going to reduce the Z tolerance a little bit. Let's make it a 75. Let's all call it BC10 75. So we can access the toolbox here in ArcScene, even though we're not used to dealing with ArcScene, and your workbook doesn't deal with ArcScene at all. We're still able to access quite a bit of the functionality that you would find in ArcMap. And so you can do things here in ArcScene and then render them in 3D, draped either on the tin or the DEM. So you don't have to jump back and forth between ArcScene and ArcMap to do analysis. You can accomplish a lot of your analysis right here. If for some reason you need to be displaying things in 3D in the first place. Okay, so when this is done, we'll display it. There we are. There's the tin with the default elevation color ramp applied, and it's automatically being displayed in 3D. We don't have to do anything to it. The tin is going to display in 3 dimensions. And so we can see the ridge lines, you can see the valleys, again, the flatter areas, the floodplain areas. And so if we used a smaller value for where I put in 75, if we shrunk that down to a smaller value, you're going to get more and more detail in the tin. It's going to show the terrain with more and more accuracy. It's going to take longer to generate it, of course, and eventually you may run into a limit where it will just fail and it won't create it because you're using too small of a search parameter. But anyway, there's things in 3D. There's some things that you can do in ArcMap to prepare data sets, clip them, and create a few important environmental data layers. And that's about all we're going to mention about this stuff here. It's a little bit longer than I thought it would take, but you have now seen how to create a number of things that you're going to need to know how to do. So I'll stop it here and talk to you next time.